So today we're going to be talking about linear functions. This is a nice review from Algebra 1. When we talk about linear functions and graphing a linear function, what are we graphing? Hopefully you're saying a line because you have the word line right there in linear. So we're talking about graphing lines. And again, hopefully a lot of this stuff is just review from Algebra 1. So by the time we're done today, we are going to be able to graph linear functions. One thing that we didn't do a lot of in Algebra 1 that we're going to pick up here is determine the slope and the y-intercept and the x-intercept, of course, but we're going to talk about what they mean given some context. Okay. So here are the standards we're going to hit. And we just jump right into it. So we know, hopefully, remember from Algebra 1 that we have to put a linear equation in slope-intercept form. This is slope-intercept form. Now, know what you may be thinking. No, you don't have to put it in slope-intercept form to graph it, but it is the most common form of a linear equation to use to graph. There are a couple other forms. The reason why this one is called slope-intercept form is because in the equation you can find the slope pretty easily and you can find the y-intercept pretty easily. So y equals mx plus b, m being the slope, so the coefficient on x being the slope, b being the y-intercept, which is going to be a constant out there for you. So without further ado, let's just get into one and review how to graph a linear function. So this is a linear function. It is already in slope-intercept form. We don't have to do anything with it. So we jump into graphing. And the first thing we're going to do is find our first point, which we get from the y-intercept. The y-intercept is where the graph crosses the y-axis. So we know that on the y-axis at -5, the line is going to cross there. So that's a point. And I think it's important right now to understand that a point has coordinates. And so the coordinates for the y-intercept here is 0, -5. We're going to use those coordinates in just a little bit. Okay, so there we go. There's the y-intercept. Then we use our slope. Our slope tells us how far you have to rise before you can run and how far you're going to run. So from -5, so from the point 0, -5, we're going to rise 2, run 3. So that means we're going to go up 2, right 3. So there's the point. And because this is a line, what makes it a line is that the slope is constant throughout the line. So we can keep going up to right 3 if we want to, up to right 3. Or we can always go down to left 3, down to left 3 to help us come up with a very nice line. Okay? And there you go. Now, do you need 6 points to graph a line? No. A couple, 2, 3 would do. But I just wanted to make sure that we understood that you can slope out a line all the way through the coordinate plane if we wanted to. Okay? All right. Here's one. Go ahead and give it a shot. Hopefully this is not going to be too tough for you. And you stop the video and then start it back up to check your answer. Did you come up with this line? So the slope, the y-intercept is at 4. So that was our first point here, 0, 4. And again, it is a point with coordinates, and so those are the coordinates. The slope was -3 over 1. Now we like slope to be a fraction. We want to see the rise and we want to see the run. So if your slope looks to be a whole number, if the coefficient on x is a whole number, go ahead and put that guy over 1 so that you can see that you have to run a positive 1. So from 0, 4, we go down 3, right 1, down 3, right 1, or we can go up 3, left 1. So down 3, right 1 gets you here, down 3, right 1 again gets you here, up 3, left 1 would get you here. So there's some points, you draw the line, and we're in great shape. Okay, little cartoon here for you. Track meet today, you got a couple of runners laying down, and I don't know, is this coach? Coach says you have to rise before you can run. Remember that when you're looking at a slope, your rise is always in the numerator. All right, now here's a linear function that is not in slope-intercept form, so we need to get it in slope-intercept form. So first thing we do, subtract 2x from both sides. We've got to move that x term first, right? Bring down that minus sign as a negative for the 5y. Then we go through and divide everything by negative 5. Yeah, negative 2 divided by negative 5 is actually positive 2 over 5. 10 divided by negative 5 is negative 2. Now we have our linear function in slope-intercept form, and we go back to what we were doing before. Put our first point on the y-intercept at negative 2. So the points, the coordinates for that y-intercept are 0, comma, negative 2. And then we can use the slope to go up to right 5, up to right 5, or we can go down to left 5, down to left 5. Now, we have a y-intercept. Y-intercept is where the line crosses the y-axis, but we can also talk about an x-intercept, and we're going to do that a little bit in these coming problems. The x-intercept, of course, is where the line touches the x-axis. That would be right here. That point is your x-intercept. The coordinates for that point right there are 5, 0. Right? So we want to understand that too, that if for an x-intercept, the coordinates for the x-intercept, the y-coordinate's always 0, and we use the number where the line hits the x-axis. For a y-intercept, the x-coordinate is always 0, and the y-coordinate is where the line touches the y-axis, that number. Right? So again, I'm making a big deal about these coordinates for these x and y intercepts because we're going to use those numbers in just a second. Right? Here's another one. Get this guy in slope-intercept form. Pause the video. Try to graph the line, and when you're done, start it back up, and you can check your answer. Okay, so when you get this guy in slope-intercept form, the equation should look like y equals negative 1/3 x plus 3. If you didn't get that, you can kind of follow the steps that I used here, and if it doesn't make any sense to you, make sure that you come in and see me during STAR. We can go through it and make sure that you know how to work an equation into slope-intercept form. From here, we should know we need a point at positive 3 on the y-axis. That's our y-intercept. The coordinates for that point are 0, 3. Since the slope is negative 1/3, we're going to go down 1, right 3, down 1, right 3. And we can do it one more time to help us get to, that's right, the x-intercept. The x-intercept here is going to be 9, 0. That's where it hits the x-axis. Okay? All right. Hopefully that makes a ton of sense. If it doesn't, again, make sure you come in during STAR and we will review graphing some more. All right. Next one. The tricky part here is you have to remember what happens when you don't see a y-intercept and you don't see a slope. Remember that slope-intercept form is y equals mx plus b. And so your y-intercept is supposed to be added as a constant, right? Well, in this particular equation, we don't see anything. Nothing's been added. No constant has been added here at the end of the function. That doesn't mean that there is no y-intercept. There is. What that means is we have to figure out what the y-intercept is. And you have to start thinking, okay, since I'm supposed to be adding a constant here at the end, and it's not shown, then apparently adding this number doesn't make a difference. So what number do you add and expect not to change anything? What number added doesn't change anything? Well, 0. So we could write in a plus 0 here if we want. It wouldn't change anything. Now, very different for the slope, because the slope is a coefficient on the x. And coefficients on the x are always multiplying into the x. Well, since we're not writing a number here as a coefficient for this x, then apparently multiplying by that number doesn't change anything. That's why we don't write it. So what number do we what number do we multiply by and not change anything? Well, that number is a 1. So if we want, we can write a 1 here. So the moral of the story is if you don't see a y-intercept in the function, then the y-intercept is 0. So we start here at 0 on the y-axis, where the coordinates for that point are 0, 0. The slope is 1, or as a fraction, 1 over 1. So we can go up 1, right 1, up 1, right 1, or down 1, left 1. And draw a nice straight line. Okay? Quick question for you, looking at this graph. Where's the x-intercept? Hopefully you're saying where the x-intercept is the same point as the y-intercept. It's 0, 0 also. That point is where the line crosses the x-axis and where it crosses the y-axis. Okay? All right. A couple more examples of lines here from functions that we want to be able to graph. Here's a guy, y equals 5. There is no x, which means that there is not a slope. The slope of this line is then, I don't know. Well, let's just graph. Y equals 5. We know the y-intercept is at 5. As a matter of fact, when the function just says y equals 5, that means that we always want the y-coordinate to be 5. So where are all the points where the y-coordinates are just 5? Well, they're all right here. Which means that this line must be a horizontal line through 5 on the y-axis. Which makes sense since the equation says y equals 5. Now look at that guy. The slope is supposed to tell you how much a line tilts. Well, how much does that line tilt? Yeah, none, not at all. So that means the slope is 0. In a horizontal line, the slope is always going to be 0. Okay? So y equals means we're graphing a horizontal line through the y-axis. X equals is a little bit different. Without even trying to figure out y-intercept and slope, we know that this equation is telling us that we want every point where the x-coordinate is -3. And all of those points are right here. So we get a vertical line through -3 on the x-axis. Okay, so if x equals is what we see, we know it's going to be a vertical line. Now, where's the y-intercept? Right, there's not one. It doesn't cross the y-axis. There is an x-intercept, and it's right here, and the coordinates for that are -3, 0, just like they would be for any other x-intercept. The slope is a little bit different. This line doesn't have no slope. It actually has a ton of slope. This thing tilts straight up and down. It has an infinite slope. And since we can't define infinity, we call this slope undefined. So for a vertical line, the slope is undefined. For a horizontal line, the slope is 0. Okay? All right. Now, slope, x-intercept, y-intercept, what do they all mean? Well, in order for them to give them meaning, we need to add some context to our functions. And we need to understand that linear functions have a place. They have a place in the real world. They do serve a purpose. Here's a linear function. Here's the graph of a linear function, right here, that helps us model Leona's newspaper job. On the x-axis, we've put how many newspapers she delivers. And the function here tells us, based on the number of newspapers delivered, how much she gets paid. When we find a point on this line, it tells us that for this many newspapers, she makes this many dollars. Okay? All right. So, question is, what is the slope and what does it represent? What does it mean? Well, we don't have the function, so we can't look for the coefficient on x. So what we do is we find 2 points with which to walk, rise, over, run. The 2 points that we're looking for are the 2 points where it crosses grid corners, right? And there are 2 points right there. So between those 2 points, you would have to rise, careful, not 1, but 5, because you're going from 0 to 5. And then you'd have to run, and again, be careful, not 4, it's actually 20, because you're going from 0 to 20. So your slope is actually 5 over 20. Now, it does reduce down to 1 to 4, but that won't always happen. It won't always reduce down to the number of grid lines that you could have counted. So let's just stick with making sure we pay attention to how the axes are scaled and counting based on how the axes are scaled. Okay? Now, what does that mean? Remember that the numerator gives you your rise, and rise is your up and down. So this numerator is your y direction. The denominator tells you how far to run, and run goes left and right. So this is your x direction. So when we interpret a slope, and we can do this every time, we interpret this the same way every time. And the way that is we can say that for every denominator, we get a numerator, right? So in other words, on the x-axis is newspapers delivered. So this says for every 4 newspapers, delivered, Leona makes $1 because her pay is on the y-axis. So for every denominator, for every x-axis, we get a numerator, or we get a y-axis. So for every 4 newspapers, she gets $1. Okay? That's how that works. Now the y-intercept is right here. That's where the line crosses the y-axis. Remember that it has coordinates, 0, 0. Remember that it's x, y, those coordinates. So what that point tells us is that when she delivers 0 newspapers, she makes $0. And hopefully that makes a ton of sense. So the y-intercept is at 0, 0, which means that if Leona delivers 0 newspapers, she makes $0. Okay, so that's how interpreting the y-intercept works. All right, let's kind of pull it together a little bit quickly on the next one, a little bit quicker on the next one. Colby puts $100 in his savings account. The graph below shows how the amount in the account would increase over the next 10 years. So on the x-axis, we've got time. On the y-axis, we have the amount in the account in dollars. Now, first thing I'm going to do is change this second question. We're not going to find the x-intercept and talk about what it represents, at least not right now. We're going to find the y-intercept and talk about what it represents. Okay, so, all right, first things first, the slope. We need 2 points where this graph crosses grid corners. There's one here, and I think the next one is right here. And now here's the problem with graphs. Graphs are incredibly inaccurate. It's really hard to tell if that line is hitting the grid corner at 10, 150 or at 9, 150. It's hard to tell. There are more accurate ways to find the slope, and we would need the function. We could write the function for this line and figure out the slope from that, but we would need 2 points, and we're back to the same problem, trying to find the second point. So I'm going to use that one, and it's going to be close enough. Sometimes you just have to estimate, and that's okay. All right, so to go from the first point to the second point, that's going to give us our slope. We have to rise 50, and then we have to run 10. So our slope is $50 over 10 years, which we can reduce down to 5 to 1. Now remember how we interpreted the slope. For every denominator, we get a numerator. Denominator's x, x is time in years. So for every year, Kobe's account gets bigger by $5. There's probably a better way to say that, but that works. For every year, Kobe's account increases by $5 is probably a better way to say it, but this works too. Okay, the y-intercept is sitting right here. The coordinates for that y-intercept are 0, 100. And so again, we look at the coordinates, and the x is 0. So when time is 0, his account has $100 in it. Now, what does that mean? At time 0, that means that Colby has just put money. It means he hasn't had the account for a year. So his account has not really started yet. So at the moment he starts it, time is 0. And what did he do? He deposited $100. So that's why the y-intercept tells us Colby deposited $100. Before the account had time to grow, that's time 0, there's no time for growth, he had $100. So that means he deposited $100. Okay? Kind of weird to think about it like that, but that's how the y-intercept, or the y-intercept works. Okay? Now, if we were to find the x-intercept, remember we had to go up 50 and right 10 to get to the next point on this graph? We can always go the other way. And if we go the other way, we can go down 50, left 10, and we would be over here at negative 10. And then we would go, so we'd be right here. We'd be at negative 10 comma 50. And we're not on the x-axis yet. So if we go down 50 more and right 10 again, we'd be at negative 20. You can't write that because we're kind of off the screen at this point. So what that tells us is that the x-coordinate, that the x-intercept is at negative 20 comma 0. The y-coordinate should be 0. That's what has to happen in order to sit on the x-axis. What does that mean? That means that at time negative 20, what's weird, that means 20 years ago, right? The account had $0. That makes no sense. Unless we can travel back in time, that makes no sense. So the x-intercept doesn't make any sense here. That's why we don't want to talk about it. And sometimes the x-intercept and y-intercept don't make any sense. Right? But I wanted to point that out. It's a good I-step question. What's the x-intercept and why does it not make any sense? Well, that's it. You can't travel back 20 years in time. Okay? All right. Hope that all makes sense. Let's try one on your own. Here we're skydiving, right? Your friends took you skydiving. We got the graph here. I'll tell you this. We don't have two nice, pretty points to use to count rise over run. Looks like you might have one there, but it's really hard to tell. And you might have one there, but again, it's hard to tell if they're exactly on those grid corners. So we are being given 2 points. And you have to remember that to find the slope given two coordinates, given the coordinates of 2 points, you have the slope formula, where you can subtract y minus y over x minus x. So do that. Try to find your slope. Try to find a way to say what it represents, and then find the y-intercept and the x-intercept, and find a way to say what it represents. All right. I'm going to walk you through this really quick to make sure you see where everything comes from. To find the slope, y minus y over x minus x, right? It doesn't matter which point you start with, but when you subtract the y's and then subtract the x's, you have to start with the same point both times. So I'm going to take 2,500 minus 2,115. That means I have to take 0 minus 35. Okay? When I do that, I get 385 over negative 35, which reduces down to 17 over negative 1. Now, pay attention to your context here. You're skydiving. The x-axis is time in seconds. The y-axis is height, right, at a given time. So if your slope were 17 over negative 1, remember that for every denominator, and the denominator is the x's, you get one numerator. The numerator is your y's. So for every negative 1 second, does that make sense? Can time be negative? No. So for our slope to be 17 over negative 1 doesn't make any sense. But thankfully for us, in a fraction, it doesn't matter where the negative is. So I can bring the negative up to the numerator, and it means the same thing. So now I can say that for every 1 second, now, we decrease our height by 17 feet, which means that for every second, we're falling 17 feet, right? And so you want to write that out, and I'm kind of out of room here. I'll try. For every second, you fall 17 feet. Okay? Y-intercept is easy enough. It's right here, 0, 2,500. Since the y-coordinate is, since the x-coordinate is 0, that means that time hasn't started yet. And the y-coordinate is 2,500, which means that before time starts, you're at 2,500 feet. Well, time starts when you jump out of the airplane to skydive. Since you haven't started yet, you're still sitting in the airplane. So you can say this however you want. The airplane is flying at 2,500 feet is one way to do that. Okay. A lot of other ways you start falling at 2,500 feet, you jump out at 2,500 feet. There's a lot of different ways you can approach that. Now, the x-intercept we can't find. So if you had a hard time finding the x-intercept, that's okay. Because, well, we don't have enough graph, number one, and we don't have good points to walk from. So what would it represent? Well, we know we'd be down here somewhere, and the y-coordinate would be 0, right? Remember that y is your height, right? So what does it mean for your height to be 0? Well, that means you're on the ground. So what would the x-intercept represent? It would represent the time it takes to land. Okay? And hopefully that makes sense. If not, again, come in during STAR, and we'll go over it some more. All right? One more. Now you don't have a graph. You actually have the function. So go ahead and find the slope, find the y-intercept, try to come up with good words for what they represent. We're talking about Charlie renting a moving truck. And the equation represents the amount Charlie has to pay for the number of miles he drives. And so it's important to understand that x is the miles, y is going to be how much Charlie paid. All right? All right, try it out. Stop the video, give it a shot, and see what you come up with. All right, what'd you come up with? Hopefully you found the slope to be 1/2. I know it says 0.5, but again, I like the slope to be a fraction. That way I can see the rise, see the run. I can see the x, I can see the y. I can see the numerator, I can see the denominator. So I made 0.5 into 1/2. Hopefully that makes a lot of sense. So what does it represent? So for every 2 x's, and x's is the number of miles driven, so for every 2 miles, Charlie has to pay $1 because the y is how much he pays. So for every x, he has to pay $1. The y-intercept is a 0, 10 because the b is 10 here. 0 means that the x is 0, which means he hasn't driven any miles. But he still has to pay $10. That must mean that there's an initial rental fee for the truck, even before you drive any miles. And that fee is $10. Okay? So you have to kind of think about what the coordinates having those particular values actually mean in the context and come up with your interpretations from there. Okay? All right, that is it. Homework's out in Canvas. Make sure you get to it and get it done. If you have any questions at all, please come find me and we'll go over this some more. Okay?